Over the past year, we've witnessed a remarkable acceleration in the use of AI tools, including integration into the workflows of many knowledge workers. Based on a promise of faster output, smarter insights, and more efficient decision-making, AI is being utilised by many workers in areas such as marketing teams, investment firms, research departments, and sales organisations. We're asking more of it than ever before and starting to expect accurate and up-to-the-minute responses as standard. But with this promise comes an emerging and often overlooked challenge. The more we require from AI, the more chances there are for inaccuracies to creep in. And AI still has a stunning ability to be confidently incorrect. So, as AI becomes more embedded in our way of working, the gap between expectation and reality becomes more visible. Welcome everyone, and thanks for joining today's webinar, Navigating the Risks of Increasing AI Adoption. My name's Nick, and I've been working at Statista for 7 years now, originally as a senior analyst and now as a global sales enablement manager, which has given me a unique perspective on AI as I've engaged with the industry as an analyst and developed tools and trainings so our sales team can realise the promise of AI. Today, I want to share insights gained from this experience, particularly around the risks of using AI for knowledge work, tasks involving research and analysis of a particular topic to create reports, presentations, or even strategic outlines. Regardless of the task, and crucially, in all cases, the author is responsible for the quality and any real-world consequences, which could mean personal accountability for gaining or losing millions. The risks of AI can be summed up in just one word: inconsistency. AI is neither good nor bad, right nor wrong, easy to use nor frustratingly tedious. It can be all of these things at different times and in different ways, which is just to say inconsistent. As we will see, there are real benefits from AI adoption, but these benefits may be less than those promised by certain AI company CEOs. To demonstrate this point, let's look at two seemingly contradictory data points. On the one hand, AI adoption is surging. Web traffic to generative AI tools such as ChatGPT, Claude, Gemini, and DeepSeek has exploded in the last 12 months. Growth is so strong that most AI providers are struggling to keep up with demand. Presumably, usage is increasing because people see value in these tools. But on the other hand, recent data also shows that public skepticism about AI is growing. Today, 44% of US consumers describe themselves as skeptical about AI, which is up from 36% just 3 months earlier. And this coincides with a reduction in the number of people who are excited, hopeful, and impressed with AI. Inconsistency explains this seeming contradiction. The more people use generative AI tools, the more they encounter unpredictable results, meaning increased adoption leads to a lowering of expectations. Now, of course, AI companies are totally aware of this persistent inconsistency and have implemented many changes to make AI tools more reliable. Features such as web search and document upload functionality allow AI tools to access accurate and up-to-date data. And the underlying models have also been improved and are now able to break down questions into a set of individual tasks which are handled separately, further increasing the model's accuracy. Yet progress has been incremental at best. Despite the billions that have been spent, even the most advanced AI tools still make big mistakes from time to time. For example, OpenAI's Deep Research tool, which incorporates an AI agent to check every source for relevancy and accuracy, is only 86% accurate, which, to be fair, is a massive improvement over the 50% of ChatGPT's default 4.0 model, but still wrong 1 out of every 6 or 7 times. So today, let's unpack exactly why AI, particularly large language models, are inconsistent, what risks this creates for you, and how to navigate these challenges safely. So what is generative AI? At the most basic level, generative AI can be understood as a technology that produces new content by following patterns it locates in existing content of the same type. So, in the case of text-based models like ChatGPT, the model produces written content based on patterns it has identified through analysing massive amounts of online text. Text-based generative AI is a subset of generative AI called large language models, or LLMs. It's LLMs that I'll be talking about during this webinar and not other forms of Gen AI such as image generation. To understand how generative AI produces new content, it is really useful to contrast it to more traditional forms of AI. So traditional AI, for lack of a better term, relies on a system of static rules to perform a task previously requiring a human. To use one of the oldest examples of AI, chess-playing programs are essentially a set of rules designed to evaluate all possible moves in response to a human player, then decide on the most optimal move. As it's based on a static set of rules, traditional AI is predictable and consistent at performing the tasks they were designed for. But predictability comes at a cost. These tools cannot be used for anything other than the narrow purpose that they were explicitly programmed for. For example, the rules for a chess computer can't be used to govern opponents' behavior in another game, like, say, Super Mario Bros., even though the use case is fundamentally the same here, that of controlling opponents' behavior in an interactive game. Traditional AI is therefore consistent, but it lacks flexibility. Generative AI is fundamentally different. In the case of LLMs, these models are created by analysing all available text on the internet with the goal of identifying patterns in how letters and words are connected. From this training, they can then create a probability model which is used to calculate which words are most likely to follow other words. This is how a response is created to the user's prompt. It is simply the most probable collection of words the model calculates should follow the text that is inputted by the user. Creating a model that can perform this type of probability modeling is, of course, an amazing feat. In effect, it means LLMs can generate a legible response to just about any legible text input, not only specific types of input the model has been programmed to handle. In other words, it overcomes the main constraint of traditional AI, its single-use nature. But there's a catch. Flexibility comes at the cost of consistency. Generative AI doesn't actually understand anything in the sense that philosophers understand thought and consciousness. It doesn't link words to an underlying concept or verify its thoughts against some external state of affairs. While it may look like the model understands the user's prompt and creates its response based on this understanding, that's not what's going on. LLMs simply calculate the most probable collection of words to follow the user's input. And the nature of probability means that if it's probably right some of the time, it's probably wrong the rest of the time. A recent Ivy League academic study tested how consistent AI models actually are, and the results were eye-opening to say the least. Even under the most favourable conditions, advanced large language models showed consistent inconsistency. In the study, researchers asked each model a series of PhD-level science questions 100 times for each question, and found that the models often gave different answers to exactly the same question asked in exactly the same way. Moreover, based on a threshold of getting the correct answer 100% of the time, the models performed only around 5 percentage points better than random guessing. While this was increased slightly if the bar for accuracy was lowered a bit, both models were wrong more often than they were right. Crucially, these issues occurred under ideal circumstances. All prompts were professionally engineered to produce the most accurate results possible. The key takeaway? Even under ideal settings, you simply can't trust the AI to be reliably right. If you need your work to be 100% or even 90% accurate, you always have to verify AI content. So what exactly does it mean to verify AI output? Look, this is probably the biggest takeaway I urge everyone to have from this webinar. Verification is not simply fact-checking. Through my work implementing AI into my research over the last 2 years, I've identified 4 key dimensions of verification: facts, sources, bias, and logic. So let's take a look at each of these in turn. The first dimension of verification is fact-checking. As I'm sure most people are aware, LLMs can hallucinate, whereby the AI confidently provides factually incorrect information. However, what a lot of people don't know is that LLMs can hallucinate even when they're accessing an external source directly from the internet. And this is a topic really close to our hearts here at Statista because we know that LLMs have been hallucinating when accessing our data. The example on this slide isn't something cherry-picked, but this was the very first example I tested of this phenomenon. And as you can see, ChatGPT has incorrectly reported 2/3 of our data about NVIDIA's employee distribution. The underlying issue here is that the LLM only has partial access to our data, so it just makes up the rest. Incomplete data is known to be a really common cause of LLM hallucinations, which is why this issue was replicable with every single premium statistic of ours that I tested. So what does this mean for you? It means that LLM output cannot be trusted just because it cites a reputable source. Much of the internet operates behind a paywall, and increasingly so, as content providers fight back against AI web scraping. Facts and statistics, therefore, always need to be verified against the source, as there's just no guarantee that an LLM has accurately represented the source data. The second dimension of verification is source selection. Most AI models are trained on data that's months or even years old. To get around this problem, basically all AI tools now include some kind of web search capability, but these tools can be inconsistent with the quality of sources they select. Without an actual understanding of the topic, LLMs can struggle to identify sources that are up-to-date, relevant, or reliable. This can mean that even if the data from the source is correctly represented by the LLM, it still might be wrong. This was precisely what I found with my first ever attempt at using deep research from OpenAI, when out of pure curiosity I asked it to perform an analysis of Statista. And information about our product offering was taken primarily from Wikipedia, which led to outdated product info being reported. And I mean, it's right there on our website, guys. Come on, it's right there. So why is this happening? Well, LLMs tend to prioritize sources which let AI companies freely access their data. But more and more sources are limiting access to AI companies in fear their content will be scraped into the next model coming out. And this means fewer and fewer sources are becoming available to LLMs, pushing them to unreliable places like Wikipedia and Reddit. The consequence of this is that not only do you need to check data against its source, but also perform a broader check to ensure the sources themselves are relevant and up to date. The workload from verification just keeps adding up. The third dimension of verification is bias. This isn't just about political or social bias, but refers to any situation where an incomplete representation of information leads to an inaccurate conclusion. This picture humorously demonstrates this point. Our would-be AI overlords didn't consider all viewpoints on the subject, and thereby missed the crucial point that pre-industrial weaponry stands absolutely no chance against a modern army. Instead, it simply sees that most wars in history were won by pre-industrial armies and concludes it should conquer us all with rocks and spears. Bias in AI can have real-world consequences, though. A very famous example of this is Amazon's applicant screening AI model that needed to be manually changed because it was actively discriminating against women. Male dominance of the tech industry led the AI to make a false correlation between being male and being a good applicant, with the result that resumes were penalized simply for indicating the applicant was female. Oops. The key takeaway here is that bias isn't just an abstract buzzword, but a real risk when using AI for knowledge work. Views presented by an AI, and in particular tools producing longer form output like deep research, need to be properly checked to ensure all perspectives on the issue have been considered, as not doing so can lead to output that is at best incomplete and at worst actively harmful. So the final dimension of verification is logic. As we said, LLMs don't truly reason. They reconstruct responses based on patterns in their training data. While some newer models do claim to be able to reason, all they're really doing is breaking down a larger task into a series of smaller tasks, which can then be executed separately. But there's no guarantee that a consistent logic will be applied across each of these smaller tasks, thereby providing output that's internally coherent. In fact, more tasks can often lead to less logical coherence. To understand this point, let's go back to the previous example of playing chess. Playing chess involves making a series of decisions about a variety of possible moves based on legal moves and what moves are likely to win. Moreover, the play needs consistency across this series of decisions, sticking with the same game plan from start to finish to execute a coherent strategy. It turns out LLMs are really terrible at playing chess. Not only do they not win very often, but they often make illegal moves despite knowing full well what moves are allowed in chess when directly asked. This point is of increasing importance with the emergence of AI agents. AI agents effectively break down a big task into a series of small tasks that can be individually performed. Deep research is a fantastic example of this. It provides information about a topic by breaking the question down into a series of planning, research, and writing tasks. However, each of these tasks may not display logical consistency, potentially undermining the overall conclusion. This, of course, means that the logic of any AI content needs to be verified before it can be used as the basis of any meaningful output or decision-making process. These findings clearly show that LLM content must be fully verified. Even if it's 90% correct, you need to check all of it, as you just don't know which 10% is actually wrong. At least some facts might be made up, some sources out of date or irrelevant, some perspectives excluded, and some premises in the overall argument inconsistent. This need for verification can't be overstated. If accuracy is important, then verification is essential. Given these risks and the time taken to verify content, you might ask why someone would want to use an LLM for knowledge work in the first place. Well, a study from Harvard Business School provides a good foundation to answer this question. The study looked at the effects of adopting AI by staff at Procter & Gamble, reporting 3 key benefits. Work was typically of a higher quality, completed faster, and the staff reported a positive effect on their emotional experience of actually doing the work. Sounds great, right? Well, the devil is in the detail. First, the time savings were significantly smaller than many proponents of AI have led people to expect. On average, individuals only took 16% less time to perform their task. While obviously this is a good thing, this is far from the near total automation promised by some AI companies. So why this difference between promise and reality? The same study also suggests an answer to this question, that users are critically engaging with the content produced by the LLM before submitting it. On the left is the content an LLM would produce on its own, while on the right is the content that humans would produce without AI. And in the middle here is the AI-human combo, which is slightly different from the human-only content, which probably indicates its higher quality, but both are a very long way from what an AI would produce on its own. It is therefore clear that we should still use AI despite the risk, because it can facilitate higher quality work in less time, but only, and I stress only, if we critically engage with the AI output, treating the AI like a team member and not simply a machine to do the job for us. Without critical engagement, AI will likely produce subpar results full of inconsistencies and inaccuracies. In the case of any work involving research, or facts and figures of any kind, these 4 dimensions of verification provide a powerful framework for critical engagement. This not only provides a way to identify inconsistencies, but also provides a starting point to build your own verification workflow. So the remainder of this webinar will focus on how you can optimize your verification workflow to get the most out of Gen AI. A powerful way to not only speed up the process of verification, but also to reduce its complexity and cognitive burden is to know which data you can trust. This saves time, as you don't need to check the facts are correct or survey a wide range of sources to make sure you've included the most relevant figures. You also don't need to search for hidden bias. This way, 3 of the 4 dimensions are covered, allowing you to concentrate on the logic behind the work, elevating it to that extra degree of quality. We here at Statista are fortunate, as it is these 3 dimensions that have underpinned our approach towards data for nearly 2 decades now. The key goal of our researchers is to create a body of facts about their topic, which are accurate, relevant, and cover all aspects of their expertise. We then format this knowledge in a way that is as easy to understand as possible, providing both a written context for each statistic, as well as visualizing it in the most intuitive format, which, fortunately for us, is exactly the kind of data that complements AI tools. Alongside providing data you can trust, another key goal here at Statista is to provide data on the broadest possible range of topics of any market research provider. This is something we have painstakingly built up by hand over the last 18 years, so that we now have a database containing over 1 million statistics from 40,000 sources across 80,000 different topics. Again, all researched by hand by a human researcher. Our platform is therefore perfectly suited to verification. Not only can facts be quickly checked against an unmatched collection of trustworthy facts, but we also provide the tools to understand these facts. The written descriptions and visualizations make it as easy as possible to understand the overall context, including identifying different perspectives within the topic. And this is crucially important, as identifying bias can be very difficult without existing expertise or extensive research, both of which is the core responsibility of our researchers. In addition to the platform, we have also integrated our data into an AI research tool called Research AI. Now, you might be excused for thinking I've just totally contradicted myself here, talking about the risks of AI, then proposing an AI solution. However, Research AI is able to minimize the risks of AI through how it is linked directly to our database of trusted statistics, meaning the risk from inaccuracy and source selection is greatly reduced. Research AI is designed so that leading-edge AI models are instructed to use data only from our database when creating their response. This means the tool will not provide an answer if it doesn't have sufficient data to do so, further leading to greater accuracy. Regarding hallucinations, it even outperforms deep research, but without the 5 to 30-minute runtime. As for help with checking the logical structure of a piece though, well, that's not really something that can be automated, but I think that is a really good thing, as it means there's still a place in this world for us knowledge workers. Reasoning is the true advantage that humans possess over machines. Adopting AI in conjunction with tools that optimize verification like Statista means we have as much time as possible to work on this final dimension. This is the dimension that truly elevates a piece of work and the basis of how to truly get the most out of AI without the risks. So that concludes the presentation portion of the webinar. Over the last 20 minutes, we saw how inconsistency is an inherent feature of generative AI as they function through probabilities, not rules. This means all AI content needs to be verified. And we saw how, for large language models, this inconsistency manifests itself via 4 main dimensions: facts, sources, bias, and logic. Finally, we saw how you can use tools like Statista to optimize your verification workflow for the first 3 of these 4 dimensions, freeing up time and cognitive capacity to elevate your work by focusing on the 4th. Thank you so much for joining me today. For those of you attending the webinar live, we'll be opening up the floor to questions shortly, so don't go anywhere. If you're watching the recorded version of this webinar via our platform or social media, thank you again for watching. For more expert-led insights from insights across industries, make sure that you sign up for future webinars so that you can have access to the data discussed in this webinar and be part of our live Q&A sessions.